Guys, welcome to Edustart now. If you haven't subscribed to my channel yet, please subscribe to the channel and follow us on Edustart now at Insta. So let us continue today's topic. We're gonna discuss about what exactly the clustering and what are the types of clustering, and also we try to see an interesting case study of the social media ads. And let us have a quick recap about what are the things which we have covered. We had covered the linear regression and introduction of linear regression, how and when, what the relationship between a dependent and independent variable is followed in regression, and how the regression analysis depends on what are the things which prioritize regression. What are the things which have been prioritized, the relationship between the dependent and independent variable. Regression analysis is widely used for prediction and forecasting the things. So dependent and independent variable, we have also seen what exactly the formula which states y is equal to mx plus c and the slope intercept form. And it's simple linear regression. We have y is equal to, technically we can also write it as y is equal to mx plus c, where c is a b naught value, y is equal to mx. This is mx. So if the simple linear regression, that means only one variable. They are multilinear regression. That means we can add up the things like plus b2 into x1 plus b3 into x3 if they are more than one variable. So this is exactly what exactly we wanted to analyze and try to understand. So next is this is the so y is a dependent variable, and x1 is independent variable, and b naught is a coefficient of the individual simple regression. Exactly the regression. So how y is equal to mx plus c and the dependent of both the simple and linear regression will come plays an important role. And also we understood what exactly the simple linear regression in terms of salaries and experience, how they are both correlated with each other. And we try to plot the data points to x-axis and y-axis and try to determine what exactly the how exactly the slope of y-intercept takes place. So we have also given an example of how the 30k this slope which gonna hit around 30k. And so if everything is increasing, where exactly what should be the amount of uh, what should be the better amount of rupees should be. This is what this graph is trying to explain. So this simple linear regression where the salary and the sum is equal to y minus y naught, um, where exactly minimum. We'll also try to find out what exactly the formula by using Euclidean distance. And we have seen a very interesting case study. So how simple linear regression and the data pre-processing can be used. So we have also seen a simple linear regression by importing the libraries like import numpy as np, import matplot as pl, and we try to import pandas too. And data set where we'll try to read what exactly the data, and what is salary.csv, where x is equal to data slot, and we have, and this is a data set which is trying to indicate. So apart from -1 we are selecting all, and -3 we are taking as independent, and then try to import cross validation and convert the data into 30 and 70 ratio splitting. After splitting, this is a code of which we have tried to split. And then this is the x value where we'll use float y test and x test, data set y test and y train, and things like that. This is the exact feature. This is the exact x train, y train, x test and y test. And then we try to predict what exactly the regressor is trying to predict, and then we'll try to visualize the results. If we try to visualize the results, it is showing as a straight line. So this depends upon the points of it, what exactly the points are showing, how much distance is been related with the slope of line, and the data points is exactly the simple linear regression. So this was a brief introduction which we have covered in the previous class. Now let us understand what exactly the clustering is. So clustering is a group of objects or group of variables which have been grouped together, and we'll try to find out what exactly the midpoint for the clustering. And from midpoint, how many points, which objects which have been lying surrounding that, we'll try to calculate. And then we'll try to segregate. So we'll also have types of clusters like hierarchy clustering, normal clustering, and things like that. So let us see what is clustering. Clustering is a process of dividing the data set into groups consist of similar data points. Okay, points in the same group are as similar as possible. So whatever the points in the points which are very near to the group, they are what meant to be in that group. So points at different groups are dissimilar as possible. So where clustering is used, the group of dinners in a restaurant where clustering in any shopping mall, or else in a grocery shops like Ratnadeep and Hyper and things like that, where all the items are grouped in a particular, so that whatever the things you required, you select from there. So this is cluster. So this is one of the cluster, and a group of people are sitting on this forms a cluster over there. So where it is used, technically Amazon recommendation system which is used as a cluster, like to give an example, like iPhone phone, if you want to buy accessories like iPhone cover, iPhone screen guard, as well as iPhone charger, they're gonna recommend you, stating that how and when, how and why the people, how and why the people of the earlier of the same group also try to purchase this. So you also might be interested in assuming that they'll try to send you, they'll give you what exactly they wanted to tell. So what exactly the so Netflix also the follow the same thing. If, say suppose movie recommendation it's gonna give. So if same age group or same locality or else same in the, say, suppose if I watch horror movies, I'm interested into watching horror movies, so Netflix is gonna give me suggestion of the next best alternative for this movie according to the recommendation. So that's what that is what where these forms are clusters and things like that. Okay, so where it is used basically, it is used in the grocery shops and banking sector and insurance companies. So they'll try to frame what exactly how many people are claiming at what age group they are trying to claim and things like that. So types of clustering. So exclusive clustering, that means hard clustering, data points items belong to exclusive only in one cluster. For example, claim in clustering. So in claim in clustering, we'll try to segregate only the data which is depending upon to that individual sector. We don't try to club these data points into this and this data points into this. So we're trying to form individual clusters among them. This is also we are trying to find individual clusters and then overlapping clusters. So soft clusters, data points item belongs to the multiple clusters. Example, C main clustering. So when the clusters are overlapped, we try to find what exactly the distance between, what exactly the point which acts as a distance between separating points, and then we try to connect the overlapping clustering and try to segregate what are the clusters which have been overlapped in this scenario. And next is also comes about hierarchy clustering, where we'll see whether a and b, a is greater than b, or else d is greater than e. So it might be a is greater than D. So we'll try to connect what exactly hierarchy level which we are calculating. Like in this diagram, if you see A to B and B to C, and A is to B, B is greater than C. Whereas in F and E and D forms a cluster. So this is what the hierarchy clustering forms around, and this is where we explain what are the types of clustering where we use and depending upon the hierarchy. So K means, let us understand what exactly K means is. So what exactly the k-means clustering is all about? K-means clustering is whose main goal is to group similar elements or data points into a cluster. So k-means represent the number of clusters in an individual clustering, and so here let us understand with the example. So here are the pile of a dirty clothes where you want to compare and want to make a cluster out of it. So the number of clusters k is equal to 3. That means we have the three customers. It seems that we have these data points within the three clusters. So these are the within the three clusters we have the data points, and now we want to club the clusters. So first step is select the number of clusters to be identified. That is, select the value for k is equal to 3 in this case. So we have three. How many clusters do you want to find? So we want to find it out three clusters, right? So three to find it out three clusters, we'll define that k object as k is equal to 3. So randomly only we have selected three distance. So randomly select three distance data point. So to measure the distance between the first point and second, to measure the distance between the first and the selected three, that is what we'll do. Calculate the first one and the last third one. This is the one. So first one and the second one, and first one and the third one. So this is the point where we try to ascertain on assign the first point to the nearest cluster red in this case. So we are trying to assign this case, and afterwards step 5, calculate the mean value indicating the new point for the red cluster. So what exactly, this is a red color, the red cluster, and this is a red cluster, and this is a red ball, and this is a red point, and we try to calculate a mean. So this is a point where exactly the mean point. So repeat the same procedure but measure the distance to the red to mean. Okay, and add a point what exactly we are calculating. So calculating the cluster mean including the very new point is what we required. So to find the cluster, 3 points belong to it. Repeat the same procedure but measure the distance to the red. Measure the distance and add the third point to the nearest cluster red. So after calculating the nearest neighbor to find it out which point belongs and how. So this is where the thing, measure the distance and add the third point to nearest. Measure the distance and add to the third point. So calculate the new cluster mean using a very new point and measure the distance. Assign the point to the nearest cluster. Calculate the cluster mean using the new point to which the cluster does not belong to. Okay, assign the point to the nearest cluster. So we'll try to assign whatever the nearest cluster to and calculate the cluster using the new mean point. And then to which clusters this points belongs to. So this cluster belongs to this point, this collector cluster belongs to this point, and this cluster try to belong to this point. So measure the distance from the cluster to the mean, that is centroid. Assign the points to the nearest cluster. Calculate the cluster using a new point since the point is located closer to the green cluster. So the since all these points are located to the closer green cluster, so all of them will be assigned to the green cluster. So result from the first iteration is that all the points are this one, and the expected points are these are the points which have been lying down to the first one, and after that original whatever the results are expected is all the red points are been allotted at one point, all the green points allotted to the blue points are allotted to blue one, the green points are allotted to the green one. This is what exactly looks like. Total variation clusters is according to the k means, it iterates what exactly the mean point midpoints is. This one it try to take the midpoints, and this one it try to take the midpoint. So it will calculate the distance what exactly the nearest points to, and then form a cluster by using a centroid of it. Okay, so again we'll start from the beginning, but we'll select the second different initial random points which we see in this. Select the number of clusters to be identified. So in this case we have we need three clusters. Randomly select three distinct data points, or any one you select from this randomly. Measure the distance between the first point the third. Selected the first and selected three clusters. Between the first point and selected three clusters. So algorithm picks three initial clusters and add the remaining point to the cluster with the nearest mean, and again recalculate the mean each time at a point which is added to the cluster. So this is what it adds to, and recalculating each time point which is nearest to the cluster. Okay, total variations with the clusters it will try to identify, and then it picks three new clusters, and the remaining clusters at the remaining points. So finally some of the variations of the each clusters within this. So total variations in the clusters we can easily able to understand what exactly is. So this is the first one, second one, third one. So first one it's all about red, and first it's green. So after that it has been what resulted taking into red highest priority, and the second one is a blue, and third one is green. So in third iteration it has completely divided all the clusters, it has completely formed all the clusters and formed into a unit. So this is where we try to understand among all the better which one is a better among which one is better in all the compared to all the three clusters. So if we have plotted this in a plotted on x-axis and y-axis, then it's gonna reflect like this. So this is a one point, this is one point, and this is a second point. And similarly if we pick the three random, and if we try to calculate the Pythagoras theorem from that centroid, we'll assign the nearest clusters including the very new point for that. So in the previous scenario k values is known to that, and this is not true always. Okay, so deciding the k value, for that you have to hit the trial method starting from k is equal to 1. Now try k is equal to 2, k is equal to 3, so k is equal to 4. Which one is a better? In the case of apart from the data validation where the case is 0, so now try with k4. So you try to use the elbow curve method. This is the elbow curve method where the elbow curve shows as 3, so we can easily make it out, stating that we can give it about three we can give about three clusters we can form by using this thing. So this is what where we have learned. So now let us understand what exactly knn speaks about. So KNN speaks about the categories and the category one. So these are the category one and category two, and we have a new point which we have calculated by using formula, and this is a new point. So before new point, we try to assign before after getting this new point, we'll try to assign the new category of the data whichever is nearer. So the point whichever is nearer, the new point is nearer to red, so we treated this as a red point. So after that, how did we do that? Choose a number of k neighbors. Take the k nearest neighbor to of the data point according to Euclidean distance. So calculate the Euclidean distance among all the point, and try to calculate whichever is the nearest one among whichever is the nearest. Then take that point as a centroid of that. Among all these three neighbors, count the number of data points in each of the category. Assign the new points to the category where you have counted the most. So let us understand what exactly this is all about. and this is a k nearest neighbor. Import the libraries like numpy as np, matplot as plot, and pandas as pd. So after that, uh, assign the new data point categories where you have counted the most. So we'll try to assign and the model will be ready. So we'll try to dissect what exactly k nearest neighbor is all talking about. So first we'll try to import numpy as n. So import numpy as np, import matplot as plt, import pandas as pd. So dataset is equal to p dot read csv of the social networking ads which we try to use, whereas x is equal to dataset doc ilog where 2 comma 3 is the values and y is equal to dataset ilog 3 is equal to 4. So we'll try to split the data into the test and training set by taking 25% of the term as test and random as 0, and where the training set would be as 75%. So future scaling from the scikit learn process, import standard scalar where standard scalar is equal to x train comma is equal to sc dot fit transform train. So in this we'll try to learn import from the fitting classifier to the train set. We'll try to import psychic dot neighbor, import the k classifier. So classifier k classifier, if we try to import when the neighbor is equal to 5, the metric is equal to miniscovic, and p is equal to 2. This is the code which I try to give, and the classifier dot fit is equal to train comma y. I'll try to figure it out how I'll try to run this code in Jupyter, and I'll show you how the graph gonna look. Okay, so give me a 1 minute to run this code. It will take some time. So predict the x test and y test by predict and x test. So to make the confusion matrix, we'll try to import confusion matrix is equal to confusion matrix test y test minus y print. I'll try to predict this code in a graph in Python, and I'll show you graphical representation. How does it look? Okay, it will take some time because the data is too huge. It will take some time to run. Okay, stay tuned. We'll be back. Yes, guys, finally I have made it. So this was a thing. This was a thing which has been was an output. So it was a predict class, and we have tried to import psychic. We tried to import from scikit learn import confusion matrix. So confusion matrix is just like a y test comma y predict. So this was exactly the y test and y predict and y predict and y test. Uh, so this was if we try to visualize, this was a code to write this code. It took a very long time for me. So because I had to look into some certain number of books and then try to predict and try to write this code. And here I have limited the plot size to x to minimum, x1 to maximum, and then try to limit. And this plot has been used scattered and color map as green and red, and you can use a number of colors and what is the size and things like that. So plot title KNN training set, and plot KNN K label as an age, and plotting Y label as estimated salary, and plot legend and print show. And if you try to run this code, this is the output. So to this output, it already took for me a 20 to 30 minutes about. So this I directly copied over here. So see, if we try to use this, if we try to understand uh, what exactly this graph is trying to explain, that there has been clearly distinguished between what exactly the cluster form between two, like green and red. So red and green. So these are the point. I can easily, I can if I easily clearly make a note that there are 7 points, which is one. This is two, and three, there is four, I guess four. So 4 points have been 4 points has been categorized, miscategorized between green, in the red segment green has formed, and in green segment red dots are formed. So this is how the clusters work, and this is how the clusters classifications can be done by using KNN test. I'll give this code. This is a very easy and very easy and um, useful code. So please try to make a note of it, and I'll post this code in a GitHub. So that's all about the today's class, where we try to learn what exactly the clustering. In the next class, we'll try to understand what exactly the CNN and ANN the CNN and ANN curves is all about. So stay tuned for the more updates. We'll be learning much more interesting, like convolutional neural networking and artificial neural networking. So and also in the next session, we'll also try to discuss what exactly how to build a resume and resume building techniques and things like that. So stay tuned. We'll be right back. So if you haven't subscribed to my channel yet, please do subscribe, and please do subscribe to my channel, and follow us on Insta. And if you have any doubt, please, and if you have any doubts, please feel free to text in the comment box. And thank you from Edustart now. Have a good day. Take care. Bye bye.